Hey Global Impact students, this is Mr. Ellinger. In this lesson, we're going to discuss using linear models. Our learning targets for the lesson, we want to write linear equations that model real-world data, and we want to make predictions from linear models. Some essential understanding for the lesson, sometimes it is possible to model data from a real-world situation with a linear equation. The equation can then be used to draw conclusions about the situation. The equation of a trend line or line of best fit can be used to model data that cluster in a linear pattern. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. A scatter plot can be used to determine the strength of the relationship or correlation between two data sets. Some background for the lesson. When data from a real-world situation can be written as a set of ordered pairs, you can use various types of regression equations as models. We will discuss correlation. It is a common mistake to conclude that because two events are correlated, one must be the cause of the other. So there's a difference between correlation and causation. It is possible, however, for two events to be correlated, even strongly correlated, without one event causing the other. It may be the case that a third event is the common cause of the correlated events. For example, houses and milk do seem to cost more as time goes by, now compared to 30 years ago. However, time itself does not cause these prices to go up. Rather, other factors like inflation and demand, which change over time, are the causes. So sometimes it is possible to model data from a real-world situation with a linear equation, and this lesson is very critical, okay? It's very critical not just to be able to write equations and draw graphs and things like that, but it's critical to be able to solve real-world problems. That's what we're after here. So you can use the equation to draw conclusions about the situation. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. You can use a scatter plot to determine the strength of the relationship or correlation between data sets. The closer the data points fall along a line, the stronger the relationship and the stronger the positive or negative correlation between two variables. This first graph, we see a strong negative correlation because the data, the cluster, the pattern, is going down from left to right. The second graph, we have a weak negative correlation. They're not quite clustered as tightly as they are in the first graph, but the general pattern is still a downward trend from left to right. The middle graph, no correlation at all. There's no pattern at all to the data points. They're not going in an upward pattern from left to right or downward. Our fourth graph here, we have a weak positive correlation. The general pattern of the data points is going upward from left to right on our graph, but they're not clustered very tightly. And then the last graph, we have a strong positive correlation, at least stronger than this graph here. Again, the data points are clustered a little more tightly, and they're going upward from left to right. Okay, so let's take a look at an example here. The table below lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. Make a scatter plot. How would you describe the correlation? So here we have a bunch of data. So each one of these data points is going to represent a month. And our two values, or our two variables in this situation, are average temperature and electricity bill in dollars. So to make a scatter plot, first thing we have to do is decide what are our variables, where do we put them on the axes. So average temperature is going to go along the horizontal axis. Electricity bill is going to go along the vertical axis. And anytime we're doing a graph, a scatter plot like this, it's always a good idea to include a title. What is it that we're looking at? Always draw these graphs when we're doing these real world problems. Always draw them from the mindset of, I have to draw something that someone who doesn't know what I'm doing in math class knows exactly what they're looking at. Be as detailed as possible. Okay? And we know average temperature goes on the horizontal axis because for this problem, the electricity bill is going to depend on the average temperature. So our independent variable always goes on the horizontal axis, and our dependent variable always goes on the vertical axis. We have to decide on a scale. So, it's very important to scale our graphs correctly. And you just have to kind of analyze the data, look at the range of the data, look at the least value, the maximum value, and decide on a scale from there. Okay? So we see our vertical axis. So we see our horizontal axis, each line represents 10 degrees Fahrenheit, and our vertical axis, each line represents $20. So here are all of our data points. All right, describing the correlation as the temperature increases. So as we progress this way, the temperature is increasing. The electricity cost also increases. Okay, so as temperature increases, the electricity bill increases. These points are relatively tightly clustered around a line, some particular line. Now there's no line drawn here, but they are tightly clustered around a line. So there's a strong positive correlation between temperature and electricity cost. One thing we know we do with scatter plots is we always like to draw a best fitting line, and that's not perfectly straight, but that could be a best fitting line, and that kind of illustrates the explanation here. Which ordered pair corresponds to January? Well, in January, we know that we have a temperature of 61 degrees and a bill of $150. So it appears as though this point right here is the ordered pair that represents January. How many ordered pairs should be graphed? Well, if you have a data table, you should graph all the points, all the ordered pairs. So using the graph, how much would you expect to pay for electricity if the average temperature was 70 degrees Fahrenheit? So this is an exercise in reading the graph. Here is 70 degrees. Okay, so this grid line here is 70 degrees. Now, so let's just say right here, whatever dollar amount this is would correspond with this point here. Well, what is this? This is 160. Okay, so we would say you would expect to pay approximately $160 if the temperature was 70 degrees Fahrenheit. All right, so the table we have here over here shows the number of hours students spent online the day before a test and the scores on the test. Make a scatter plot. How would you describe the correlation? Some questions to think about. What scale will you use on the horizontal axis? What scale will you use on the vertical axis? So go ahead and pause the video. Maybe draw yourself a quick scatter plot and see what you think the correlation would be. Okay, so there's my scatter plot. And what we should be able to see here is that there is a downward trend in our data from left to right. Okay, it's going this direction. So we would say that this is a negative correlation, and I think it would probably be safe to say that this is a strong negative correlation. What we can imply is that there's probably a good relationship, causal relationship between the hours spent online the day before a test and the test scores. And I don't believe that in this case this is talking about hours spent online doing schoolwork. This is probably hours spent online doing other things. Okay, so as more time you spend online, the lower your test score is going to get in general. Okay, so here we have another example, that a table, median home prices in Florida. What is the equation of a trend line that models a relationship between time and home prices? Use the equation to predict the median home price in 2020. So here we're taking this a step further. Not only are we getting a scatter plot, but we are establishing a trend line, and then we are writing the equation for that trend line. So here we have our data, we have years, and we have median price. Anytime we're working with years, we're probably not going to want to use the exact value of the years, 1940, 1950, 1960, and so on. What we want to do is we want to take our first year data point. If we're not told how to define this, what we want to do is we're going to build all of our, you can see the horizontal axis down here on the graph. What we're going to do is we're going to establish the first year that we have. That is our 0. That's our starting point. Okay? And then every year after that is going to be represented by a number. How many years since 1940? So this 1950, when we go to actually graph and do calculations, this is going to represent 10. 1960 is going to represent 20. And so on in this manner. So that's how this scatter plot is established down here. That's why you see 10, 20, 30, 40, 50, 60, and not 1940, 1950, and so on. So we made our scatter plot, letting x equals 0 correspond to 1940. And then what we did was we sketched a trend line. Okay, now remember, trend lines, you know, we could all have the same scatter plot in our hands, and we could all draw a slightly different trend line. Good rules of trend lines. You should try to get equal points on both sides of the trend line. Hit as many data points as possible. Sometimes that's good, sometimes that's not. And we'll talk more about other techniques that you can use to establish good trend lines. But for what we're doing, we want to be able to write an equation. So our trend line should contain 2 data points because, remember, in order to write an equation, we need to know a slope and a point on the line. The only way we're going to get a slope in this case is to have 2 data points. So we need to make sure that our trend line goes through 2 data points. So the 2 data points that this trend line goes through are 10, 40,000 and 55, 110,000. Okay, right here. So those are our 2 data points. So, using our techniques that we have, we come up with an equation of y equals 1,556x plus 24,440. Okay? Now let's just talk about this here real quick. This 24,440. This should be our approximate value of the y-intercept. So the y-intercept of the trend line, if you'll notice, that's when x is 0. This value doesn't match up quite with the actual value when x was 0 in 1940, but it's fairly close. And they will differ unless you use your y-intercept as one of your points for your equation. So that is okay. So use the equation to predict the median home price in 2020. So now that we have this equation, we can substitute in 80 for x and solve for y. So based on the trend line, the median home price in 2020 will be around $149,000. Okay, so the trend line that gives the most accurate model of related data is called the line of best fit. One method for finding a line of best fit is what's called a linear regression. I'm going to show you here in just a second how to do a linear regression on the TI Nspire. The correlation coefficient R that's generated when you do this on your calculator indicates the strength of the correlation. The closer the R value that you get is to 1 or -1, the more closely the data resembles a line and the more accurate your model is likely to be. Okay, and if you think about that for a second, trend lines aren't exact. So this R value that we get is probably not going to be exactly 1, but the closer we can get to 1, the better. So like a 0.92 or a 0.93 up to a 0.99, those are going to be good R values. If it's less than 0.9, then there's probably a better trend line that we could generate. So here we have some data. You research the average cost of whole milk for several recent years to look for trends. The table shows our data. Right? What we want to do is we want to view a scatter plot of the data. We want to discuss the correlation in the data, and we want to be able to find a linear model for this situation using the TI Nspire. So at this point, I'm going to show you how to do this on the TI Nspire. All right, everybody. I'm going to show you how to enter data into a list in a spreadsheet on your calculator. And then once we do that, we can generate a scatter plot, and then we can do whatever type of regression we want to do, but we're going to do a linear regression here. So what you see here is my calculator software on my computer, and what I have over here to the left is all the keys, and instead of having a screen here above, I've got my screen over here on the right. Okay, so I'm going to go back to my home screen. Anytime that I'm ready to do anything beyond a basic calculation or a graph where I'm just doing scratch work, I need to come over here and make a new document. Okay, so let's make a new document. Now it's going to ask us, well, what type of document do you want? What are you going to be doing? Here we're going to be doing lists and spreadsheets. So once I get this list and spreadsheet open up, what I'm going to do is here you see the A, B, C, D, these are the header columns. So first thing I'm going to do is I'm going to arrow up into the header column, and I'm going to name my headers. And you can use X and Y if you want to. You can actually name them based on what your problem is. Then arrow over. So we're going to put years in the A column, and we're going to put cost in the B column. All right? And then once we do that, this equals row here, we don't want to mess with that right now. So what we do want to do is we want to start putting our data in these cells. So in the number 1 row, we're going to start with our first year. And again, we want to use years from 1998. Okay, so since 1998 is our starting point, we're going to make that 0. And then 2000 is going to be 2, 6, 8, 10. All right, and then we'll come over here in our cost column and we'll put the corresponding costs, 2.65. Okay, so we have our data entered in. Now that we have our data in, we have our own table on our calculator. What we're going to do is we're going to go over here to menu. And then from this menu, we want to let's do a quick graph. Okay, so anytime you have a data table and you want to see what it looks like, let's do a quick graph. Now, when you get to the quick graph, the problem with it is all that it's displaying is the cost, because that's the last column that we are working with. What I want to see is I want to see years down here and I want to see costs over here, and you see there's a box that says click to add a variable or click to change the variable. So let's just click in here and let's make this years. You can see the points move because right now it's just displaying years. Let's go over here and put the cost in, and it changes your data. There is our scatter plot of the data. Okay, so there's a picture. Right away we can see we have a positive correlation. Okay, so after we have our data entered into our table, we want the calculator to do our regression calculation for us. So we're going to go into the menu and we're going to use the statistics menu, and we want to have it do some stat calculations. So there are many stat calculations that we can do. If you're doing mean, median, or mode type of things, one variable statistics is what you're going to want to choose. Okay, well, you can see we have all different kinds of regressions, and we'll get into a lot of these later. But we want to do a linear regression, and you see there's 2 of them. Let's choose the mx plus b. And what we have to do is we have to tell the calculator, what do you want the x list to be? We want that to be the years. And the y list is the cost. Everything else we can just leave it. Just click OK. And you can see right in our spreadsheet, they go ahead and put the regression in for us. And you can see, if you've ever worked with Excel or numbers, this equals row is where we get formulas. So they put a formula in here for us to use our data that we have in here to do this regression. So here we have M is 0.093429, B is 2.61952, R squared, get to that later, R is 0.9196, so R is about 0.92. Since R is 0.92, that's fairly close to 1. So this is a good regression model. It's not perfect. If it was perfect, it'd be 1. R would be 1. We really can't have an R value of 1 unless all the data line up perfectly on the trend line. So that's how we do a simple linear regression on our calculators. Okay, so the model that I got from the TI Inspire is y equals 0.093x plus 2.62, I'll call it. So based on our model, how much would you expect to pay for a gallon of whole milk in 2020? Well, 2020 is 22 years after 1998. So the value of x that we're going to evaluate our equation for is 22. And that equals approximately 4.66 repeating. So based on our linear model from our calculator, how much would you expect to pay for a gallon of whole milk in 2020? Write a sentence to answer the question. We would expect to pay $4.67 in 2020. Okay. So like I said, guys, this lesson is very important. If you take a statistics class, you're going to get into this a lot more. You're going to talk about the correlation coefficient a lot more, different types of regression a lot more. But for now, what we have to be able to do is we have to be able to take data. We have to be able to display the data. We have to be able to model the data with a trend line and then write the equation of that trend line and then use that equation to answer questions, make inferences about our data, whether they're within the data set, which we call interpolation, or whether they're outside the data set, which we call extrapolation. This last example that I did here, this question that I answered at the bottom, this is an example of extrapolation. Going beyond the data is extrapolation. Okay? Hope you guys have a great day.